Can't do that. Cross it out, can't do it. It's impossible. Because truthfully, on your calculator, if you try to take the square root of negative 25, it's not negative 5, it's an error because it's not real, right? Non-real answer. Non-real, something's not real means it's imaginary. Okie doke? So this is the world we're going into. So right at the top there, we've got the definition of an imaginary number. I is, and that's like kind of a little scripted I, is the square root of negative 1. So in the first section, if you're taking the square root of negative 9, the square root of the negative is your I, and the square root of 9 is 3, so that would just be 3i. In B, the square root of 100 is 10, and the square root of a negative is I, so that would be 10i. Do you follow? The next one, does anybody in here know the square root of 32 off the top of their head? No, because 32 is not a perfect square, but we can break it down, just like we did in the radical chapter. So what does 32 break down into? 16 and 2. So you've got the square root of, and I'm going to keep the negative with the 16. So it's because it's really negative 32, which would break down into negative 16 times 2. Because the square root of that negative 16 is what? 4i, and then you just hang on to your root 2. So how should I break down negative 18, would you say, Haley? Perfect. So the radical negative 9 becomes 3i, root 2. Okay? So this now is going to bring us into solving quadratics, which before, if you tried to take the square root of a negative, you would stop and you would say, there's no solutions. But there are solutions. There are no real solutions, but there will be imaginary solutions. So in part A, if you're solving this, why don't we need the quadratic formula here? Why don't I need the quadratic formula? Anybody? Owen? No, we are solving. It says solve. It is an equation. Corey? Right. There's only the x squared term, and there's constants. There's no x term, plain old x term. So I can just isolate the x squared by subtracting 8 on both sides, dividing by 5 on both sides, and I'm solving it technically. If you're not solving by the quadratic formula and you're not solving by factoring, you can solve by square root, which take the square root of both sides, and what does x equal? Close. Anytime you take the square root of both sides, you have to remember plus or minus 2i. So we weren't wrong in the past when we said, oh, there's no solutions, because all we knew was the real number system. There aren't any real solutions, but there are imaginary solutions, and those are the ones. Okie doke. On the next one, same thing. We don't have an x term, so just subtract your 20. How do I get rid of that 1/2? Beautiful. Multiply by the reciprocal 2. Square root both sides. X equals what thing? Perfect. Plus or minus 6i. Good. So we get the point here. Yes? Something that you should start to realize, and I'll keep pointing it out as we go through, is that imaginary answers come in pairs of 2. It is impossible to have one imaginary answer. You can have 2. You'll see as we move forward, you can have 4, you could have 6. They come in pairs of 2. So you can't just have one answer that's imaginary. Okay? And I'll continue to show you how that develops. In the next exercise, just basic operations are the same. Combining like terms is the same. Although this is a multiplying, right? 5i times 6i, what is 5x times 6x, Jack? Side question. Jack Taylor. What's 5x times 6x? Nope. 30x squared, correct. Right? X times x is x squared. Same thing with i's. 5i times 6i is going to be 30i squared. But here's the thing. What was I? Go back up to the top again and look at the main piece here, that I is equivalent to the square root of -1. So if I'm squaring that, what is an I squared going to become? What happens with a square root and a square? They cancel. So that's just going to turn into -1, and it's back to a real answer. So here's this next section that I write out for you. Your final answers should never have an exponent on the I. And I'm about to tell you why. I alone stays I. I squared, though, becomes -1. I cubed, I'll tell you first that it's just -I, and then I'll explain why. Because I cubed is the same thing as I squared times I. Can we all agree with that, with our exponent rules? I squared times I is a replacement for I cubed. And since I squared is -1, -1 times I is -I. Everyone see that? And I to the 4th, I'll tell you first, is just +1. And the reason for that is because I to the 4th is I squared times I squared, which is -1 times -1, which is 1. And then the cycle continues, and it's just going to go through this same rotation from I to -1 to -I to 1. So when we get to I to the 5th, we're back to just I. And again, the reason for that is because I to the 5th is I to the 4th times I. And we just learned above that I to the 4th is 1. And 1 times I is I. You follow? I to the 6th is back to -1. Again, the logic behind that is that I to the 4th times I squared would replace I to the 6th. And I love seeing I to the 4ths, or I to the 8ths, or I to the 12th. I to any multiple of 4, because this part will always just be 1. And then I squared is -1, and so that's why we land at -1. Okay? So here's the important piece, and we're going to get to it in exercise 5. I know some of these numbers are hard to see on the screen, but that's I to the 38. At least that's what we're going to treat it as. No one expects you to kind of count through to get to 38. But what we are going to use to our advantage is what I just mentioned, is that I to the 4th equals 1, I to the 8th equals 1, I to the 12th equals 1. Any multiple of 4, I to that power will equal 1. So if you're looking at 38, and we're thinking about breaking that down, what's the first number under 38 that 4 goes into, Bella? 36. So I would break this up into I to the 36 times I to the, if I want 38 total, I'd need I to the 2nd. And I like the I to the 36 because that's just 1. So I can just pretty much cross it out. Or if you really want to show it, you can say 1 times, and what's I squared? -1. And 1 times -1 is -1. So I to the 38th power is -1. Good? Does that make sense? So our focus is on what's the multiple of 4. So how would you break down I to the 21st power, Jason? There's a bigger one. Go up 4 more. I to the 20th times I to the 1st. And the I to the 20th just cancels. And I to the 1st is just I. This is I to the 83rd. How would you break that one down? This. To the 32nd. That's an 83. So what's the first number under 83 that 4 goes into? 80. And this one would then have to be a 3. So the I to the 80th cancels. And I to the 3 is negative I. What you really need to memorize is I to the 1st, I to the 2nd, I to the 3rd, and I to the 4th. Because then whatever's left over, that'll be your answer. And in D, I to the 40th already is a multiple of 4, so that's just 1. Any questions? Now I've got great news for you. There's an I button on your calculator. Above the decimal in blue is a little I. So if you hit second and the decimal sign, it's going to be bringing I up onto your paper or onto your screen. And if you raise it to the, let's do the 83rd power. Oh, that's not very helpful, is it? Okay. Did anyone say that? I'll get back to you. So I guess it depends on what model you're using, but I feel like it might be a setting I can change and tell you guys what to put it as. So I do still want you to understand the logic behind it, because the Common Core will find a way to ask you something like this and ask you what that is, right? And that's going to be I to the 4x times I to the 3rd. And you're going to have to know that if x is an integer, that'll just be 1 because it's a multiple of 4, and that you're going to have to go to I to the 3rd. That's something your calculator would not be able to help you with. They're crafty at making sure you can't use your calculator. Okay? What? Well, they want you to understand. They don't want you to be operators of calculators. Okay, so quickly on the back. As far as adding, subtracting, and multiplying, it's just like you would do with x's. So if you're adding 2, you would just combine like terms. If you're subtracting 2 binomials, you're going to distribute first. So 5 plus 3i minus a 2 minus a negative 7 would be plus 7i. And then when you combine like terms, 5 minus 2 is 3. And 3i plus 7i is 10i. So nothing new there. You do the same thing as you would do with x's. This one is the sum, so that's adding. If you go down to the multiplying section, I'll do part B. You're still going to FOIL just like you would. Negative 6 plus 4i plus 18i and then minus 12i squared. So when you combine like terms, you've got negative 6 plus 22i minus 12i squared. But what did I tell you about your final answers? You can never have a what on your I. An exponent. So you have to then say to yourself, okay, what did I squared equal again? And this is the one that's going to come up most often. I squared is negative 1. So what's going to happen to the minus 12 times negative 1? Plus 12. And then you're going to combine your constants. Negative 6 plus 12 is 6. And then you just have your plus 22i. By the way, your I term always comes second. It's your constant, 6, plus your I. The format is A plus BI. This is your regular number, and this is your imaginary portion. Okay? So, a new world to get ourselves into. You know you're excited about it. I'm going to put up your new flashcards, and we'll have that tomorrow. And these imaginary I1 through I to the 4th will be on there, FYI. So make sure you look at what that looks like when I upload the document in about 15 minutes.